Have you ever wondered what Earth might look like a billion years from now? What transformations will reshape our planet and all life on it? Let's embark on this incredible mental journey through time. Don't forget to hit the like button and subscribe to the History and Mythology channel so you don't miss our upcoming fascinating videos. We are currently living in an era where our understanding of the Earth and the natural processes shaping it is advancing at astonishing speed. Looking a billion years into the future, I foresee stunning metamorphoses driven by natural forces over this vast expanse of time. Earth's geological processes will continue their timeless symphony, orchestrating formations that will give rise to new continents, mountain ranges, and oceans. Imagine that a billion years from now, the system of tectonic plates, the primary driving force shaping Earth's topography, will have radically changed. Continents, like pieces of a giant puzzle, will drift, collide, and separate again with unwavering grandeur. Massive plates, such as the Pacific and Eurasian plates, will continue to interact at collision zones, giving birth to majestic mountain chains. Collisions are possible, for instance, between the African and Eurasian plates, which could lead to the emergence of a new mountain range, potentially dwarfing even the modern Himalayas in scale. In this new geographical reality, I anticipate vast oceans might form, interspersed with immense landmasses that redefine humid equatorial regions. Some present-day continents might be submerged, while new landmasses rise above the surface, offering a captivating spectacle for future explorers. I envision South America and Africa reuniting, forming a single vast supercontinent, much like Pangaea once existed, establishing a unique kind of ecological equilibrium. Life on Earth will also undergo profound changes. Amidst a changing climate and landscape, the animal and plant kingdoms will evolve, with dominant species adapting to their transformed habitats. Mighty trees, with roots reaching deep into the soil, will likely develop new adaptations to cope with extreme solar radiation and other adverse factors. Over this period, mutations and adaptive mechanisms will lead to the emergence of astonishing life forms, perhaps beyond our current comprehension. Radical transformations in ocean ecosystems are also likely, becoming home to hitherto unseen flora and fauna. Peering into the ocean depths, I can imagine new species of fish and marine mammals, adapted to warmer waters, coming to dominate the food chains. New ecosystems will arise from the evolution of diverse microorganisms and plankton, which will likely form the base supporting a multitude of marine inhabitants. But what about humanity? What will our fate be in such a distant future? Perhaps by then, human society might have taken a completely different developmental path, or perhaps its existence might be definitively and irreversibly ended amidst radical climate and ecological shifts. We could find ourselves on the threshold of a new era where the human presence is merely a faint echo of our past achievements. Looking ahead, I speculate that we will either manage to adapt and survive the growing challenges or vanish, leaving behind only fossilized imprints in the geological strata testifying to our existence. Thus, we face a prospect of grandiose transformations of Earth, where we move along the axis of time with the planet. These changes, simultaneously awe-inspiring and daunting, will remind us of the uniqueness and fragility of life. This fills me with hope for a future full not only of mysteries, but also of new possibilities. Plate tectonics, though a result of complex interactions within the Earth, sets the pace for processes that significantly impact life on the surface. Let's delve deeper into exactly how this happens. Today, we know Earth has a layered structure with distinct physical and chemical properties. The lithosphere, its outer rigid shell, consists of plates that move and interact. These plates don't just define continents and oceans, they form zones where geological processes are highly active. When plates collide, they create subduction zones, where one plate slides beneath another. This process can lead to the formation of deep-sea trenches in the oceans and the rise of volcanoes, like those in the Pacific Ring of Fire. Subduction zones are often associated with powerful earthquakes, further highlighting how plate movements reshape the Earth's surface and create potentially hazardous conditions. The collision of continental plates, such as the Indian and Eurasian plates, resulted in the Himalayas, colossal mountain ranges embodying the power of tectonic forces. Besides collision, we must also mention divergence, the process where plates move apart. At divergent boundaries in the oceans, mid-ocean ridges form. This allows mantle material to rise to the surface, creating new oceanic crust. Interestingly, the expansion of one plate can initiate the formation of new ocean basins. An example is the East African Rift System, which continues to grow and evolve, confirming ongoing tectonic activity. Beyond altering topography, plate tectonics plays a huge role in shaping climate. Oceans act as colossal temperature regulators for the planet. Changes in their configuration and structure can significantly transform climate patterns, which in turn affects flora and fauna. For instance, if continents begin to converge, forming supercontinents, the climate there will likely become more extreme. Such conditions could decimate familiar ecosystems, leaving only those life forms that manage to adapt to the new realities. Thus, processes at the tectonic plate level are intricately intertwined with the evolution of life on the surface. Animals and plants capable of adapting to changing conditions survive and evolve, while those unable to keep pace with the changes disappear. Therefore, plate tectonics isn't just a geological theory. It's a fundamental factor determining the history and future of our planet. The evolution of life on Earth is also predetermined by changes occurring at the plate level, representing a complex and at times dramatic process. Every moment of plate movement accumulates history, shaping new ecosystems and causing the extinction of old ones. Lifting the veil of time, I must touch upon the fate of supercontinents. Each time continents merge into a single landmass, large-scale transformations occur not only geographically, but also in Earth's climate context. When Pangaea broke apart about 200 million years ago, the consequences were diverse and long-lasting. Continents began to drift, new oceans opened up, posing a significant challenge to ecosystems. Every shift of the continents triggers climate changes and alters the habits of animals and plants, potentially causing extinctions and the emergence of new species. Evolutionary diversity has largely depended on the conditions created by tectonic processes. One key aspect will be how new unified landmasses affect the atmosphere and climate overall. When continents reassemble, it will likely create new coastlines. Along these coasts, the climate might become more temperate due to increased vegetation cover. Conversely, the interior regions of the new supercontinent could face hot and arid conditions, while areas bordering the oceans would be more humid and habitable. However, the impact of such a massive convergence won't be limited to temperature fluctuations. Geological events like volcanic eruptions and earthquakes occurring at the boundaries of the new plates will also radically alter the continent's landscapes. These processes shape new ecosystems where some life forms may decline while others thrive. Behind tectonic activity lie flows of mantle material that sustain this dynamic. The state of the oceans will also change as vast landmasses obstruct and redirect ocean currents. This will lead to shifts in weather patterns not just within the new continent, but across the entire planet. Consequently, this could catalyze changes in the animal and plant world. Such changes might either reduce overall biodiversity or, conversely, foster the emergence of life in new forms. The problem is that predicting the precise consequences of such large-scale movements is extremely difficult. It's likely that, following the formation of a new supercontinent, similar to what happened with Pangaea, the world's flora and fauna will be forced to adapt to entirely different conditions, and only the most resilient species will survive the variable climate. In this hypothetical scenario, perhaps the very concept of climate management might arise. As scientists and ecologists try to understand these changes and minimize their negative impact on the environment, developing new technologies that function in harmony with a changing Earth will become an integral part of human existence amidst new geographical realities and potential ecological upheavals. It's important to remember that this process isn't unique or specific to our era. Numerous supercontinents in Earth's history, like Gondwana and Laurasia, underwent similar processes. They experienced millions of years of evolution and climate shifts, always in a state of constant transformation. Thus, the approach of a new supercontinent raises many questions. Which organisms will survive? What climate will characterize this new world? How will human life change against the backdrop of a global landscape transformation? Humanity will face challenges that need resolving within new geological conditions. This, in my view, will demand wisdom and a readiness for change. Mountains are the result of complex interactions between lithospheric plates. When two plates converge, forces arise capable of raising majestic mountain ranges. Systems like the Himalayas serve as vivid examples of these processes. But what will happen to these mountains millions of years from now? It's expected they might either grow taller or, conversely, succumb to erosion and other natural factors. When discussing mountain formation, plate tectonics remains the primary mechanism. However, it's crucial to consider the natural forces that contribute to landscape change. This includes not only mountain uplift, but also their gradual erosion. For example, even the grandest peaks, like Mount Everest, cannot escape the effects of erosion. Over millennia, wind, rain, and snow wear away softer rocks, gradually exposing more resistant minerals, shaping the mountain topography we see today. The complex process of orogeny, mountain building, continues ceaselessly under the influence of natural phenomena. Volcanoes located near mountain ranges also contribute. Past eruptions could have enriched surrounding areas with minerals, which in turn influenced erosion processes and ecosystem formation around these mountains. I imagine grassy plains or even forests emerging over time where major eruptions once occurred. Consequently, each mountain becomes a sort of pillar for living nature, supporting and nurturing life on its slopes over time. Mountains, like everything on Earth, are subject to environmental influences. Intense climate changes, continental drift, and sea level fluctuations affect the speed and nature of these processes. But this also creates unique ecosystems capable of demonstrating remarkable resilience. For instance, life on mountain slopes can astound with its diversity of animal and plant species that have found refuge in these extreme conditions. And what about the future? Scientists predict that millions of years from now, mountain systems like the Tibetan Plateau or the Alps will leave behind traces not just as peaks, but as complex plateaus or rocky formations we can only dream of now. This will happen not only due to tectonics, but likely also influenced by human impacts on near-planetary ecosystems. Our mountains may seem immutable now, but their fate is inextricably linked to the constant processes within the Earth's interior. Mountains continue to grow, altering the landscape with each earthquake or volcanic activity, underscoring the perpetual cycle of transformation involving all elements of nature. Each peak, each canyon, is not only a testament to Earth's power, but also a chronicle of its evolution, reflecting millions of years of mountain range uplift and simultaneous erosion. Interestingly, over millions of years, weather patterns have changed, contributing to both the creation and destruction of peaks. Indeed, each stage of a mountain's life can be seen as a separate cycle, from its birth to its slow, inevitable decline. It's an endless dance where each mountain summit holds a history full of grandeur and simultaneously humility before the elements. So what will happen to future generations of mountains as tectonic plates continue their journey? We can only observe and study the unseen life forms and changes occurring on their summits. Natural disasters, unfortunately, are an inherent part of life on Earth, altering its face and impacting its inhabitants. Every year, dozens, if not hundreds, of earthquakes occur in different regions of the planet, capable of causing destruction, changing topography, and even creating new ecosystems through subsidence and collapses. These events bring not only physical changes, but also profound social, economic, and cultural consequences, confronting us with questions of survival and adaptation. Earthquakes arising from the movement of lithospheric plates often strike suddenly, making them extremely dangerous. In just a few moments, cities built over centuries, housing millions, can be reduced to rubble. However, despite their destructive power, earthquakes can also open up new opportunities. For example, strong tremors might expose new mineral deposits, and chances arise for developers ready to rebuild and modernize affected areas. Infrastructure designed using best practices and modern technologies can withstand nature's impact, though this remains a complex challenge. Volcanic eruptions are another significant factor capable of radically changing the landscape. Eruptions can be devastating, causing landslides and mudflows, but they also enrich soils, making them more fertile. Thus, life, seemingly dying, is actually just redistributed, making way for the formation of new ecosystems. Not all volcanoes behave the same way. Some remain relatively calm, while others exhibit high activity, requiring residents of nearby areas to be constantly prepared for changes. However, despite our close connection with nature, we must realize that fully controlling the elements is impossible. Numerous technologies exist for monitoring seismic and volcanic activity. Yet nature's unpredictability will always remain our vulnerability. To prepare, we need to implement strategies aimed at minimizing damage. This might include constructing earthquake-resistant buildings, creating effective early warning systems, and actively involving local communities in emergency planning. Education and awareness play a key role in mitigating the consequences of natural disasters. Training programs should include information on how to act during a seismic event, safe shelters, and creating home emergency kits with medicine and food. Furthermore, it's crucial to continually modernize infrastructure to meet current safety standards. Technically, progress in forecasting allows for more accurate data on the probability of earthquakes and eruptions. The use of satellite data and seismic monitoring aims to improve our understanding of processes deep within the planet. The coming decades promise to be revolutionary in this field, opening new prospects for reducing risks associated with natural catastrophes and allowing us to prepare in advance for emerging challenges. Thus, I believe that amidst all modern technologies, preparing for natural disasters remains a paramount task requiring active participation from various societal levels. Overcoming the aftermath of disasters is not only our responsibility to ourselves, but also to future generations who may face the same dangers we do. Another critically important aspect is climate. The further we look into the future, the higher the probability that the climate will continue to change. Global warming and its consequences are no longer just abstract discussions. They are actively manifesting on the planet. How will new environmental conditions affect flora and fauna? Which species will be able to adapt, and which will face the threat of extinction? In recent decades, I've observed stark examples of climate change driven by both natural cyclical processes and human activity. The average global temperature is gradually rising, prompting increased activity in both plant and animal life. Glaciers, which have held vast ice reserves for centuries, are now rapidly melting, releasing enormous amounts of water and carbon dioxide, leading to rising sea levels and altered ecosystems. How are our ecosystems responding? Some species with flexible adaptation mechanisms are successfully adjusting to the new conditions. For example, many plants are now starting to grow in places previously covered by snow, colonizing the newly available land. However, such changes are not always beneficial for everyone. Species favoring warmth, including some native flowering plants, are beginning to displace species that previously dominated certain regions. Animals, in turn, are also feeling the pressure of climate change. Many are migrating in search of suitable habitats to survive increased temperatures and altered environments. These movements can cover significant distances, creating new competitive relationships between species that had never previously interacted. I've witnessed such competition among birds in Europe, where warm air currents from the south led to population booms in migrating species, which then began occupying the ecological niches of traditional bird species. However, not all organisms can adapt quickly. Some species, due to their physiological characteristics, for example, cannot effectively cope with rising temperatures. Numerous studies show that vulnerable species, like polar bears and certain types of turtles, face shrinking habitats and could ultimately end up on the brink of extinction. Their traditional way of life, dependent on glaciers and specific food sources, is literally disappearing along with the collapsing ecosystems. In the final stage of global warming's impact, we encounter the emergence of new infections and diseases that spread more actively in a changing climate. For instance, changes in temperature and humidity can facilitate the spread of diseases previously confined to specific regions. This creates new risks not only for animals and plants, but also for human health, as we share space with predators and parasites that become more active in the new conditions. Thus, climate change exerts a multifaceted influence on Earth's flora and fauna. The success of species adaptation will be determined by their ability to respond to these changes. And, unfortunately, not all species will be able to do so. We must recognize that future conditions will require a conscious approach to using natural resources and maintaining biodiversity. New ecological realities will demand comprehensive understanding and strategies to mitigate the impacts of climate change, ensuring the survival not only of humanity, but also of the rich diversity of life on our planet. With every passing million years, the continuous process of life's evolution continues on our planet, resulting from countless interactions between organisms and their environment. Life on Earth has always been under pressure from various factors: climate fluctuations, geological transformations, and even the impact of human activity. Each new stage in Earth's history intensifies questions about how life can adapt to conditions radically different from those organisms were previously accustomed to. In such a dynamic environment, both mass extinctions and periods of flourishing occur, leading to the emergence of new species. Let's imagine that global warming continues to escalate. Consequently, we might face drastic changes in habitats. Rising sea levels will engulf vast coastal areas that are home to many species. With increasing temperatures, changes in the composition of flora and fauna will occur. Ocean ecosystems subjected to prolonged exposure to increased acidity will become unhealthy, leading in turn to the extinction of local species dependent on this delicate balance. However, despite all these challenges, life finds ways to survive. Exploring the possibility of new life forms emerging, I would note that, as history shows, most species capable of adapting to change will likely adopt organizational structures and physiological traits, allowing them to move forward confidently amidst chaos. In conditions far from familiar, we can expect the emergence of unique life forms evolving on entirely different principles. For example, species focused on symbiotic relationships might develop in search of protection from fierce competition for resources. This could create new ecosystems based on interactions previously unseen by us. For instance, some insects might acquire the ability to survive where others find neither food nor water. Instead of the familiar chlorophyll, plants might develop an entirely different photosynthesis mechanism capable of functioning at extremely low light levels, sustaining life even in the harshest conditions. Indeed, adaptation will be the key factor in future evolutionary processes. We must not forget the potential consequences of changes in the biosphere and climate. The emergence of new diseases and epidemics could significantly impact existing species, some of which might even evolve, reaching a radically new level of interaction with their environment. For example, mosquitoes and other insects adapted to high temperatures might alter their metabolism or even adapt to a new diet in response to the disappearance of familiar food sources. Earth, like a living organism, constantly rebalances itself in response to changes. The appearance and disappearance of life forms are always closely linked to changes in climate and habitat. In the event of a major climate catastrophe, the requirements for species survival will become stringent, but evolution will not stop, expanding the boundaries of understanding what it truly means to be alive. Age-old processes, comparable to the changing forms of life, continuously shape new behavioral patterns and adaptive mechanisms in organisms that manage to thrive even in extreme conditions. This is the constant process of life on Earth, and herein, in my opinion, lies its grandeur, which is difficult to overestimate. Oceans cover most of our planet, and changes within them are becoming increasingly noticeable against the backdrop of global climate shifts. Seawater temperature continues to rise, affecting the entire ocean ecosystem. Primarily, rising temperatures cause the gradual destruction of coral reefs, which are among the richest and most diverse places on Earth in terms of biodiversity. First comes coral bleaching, when their symbiotic microorganisms, providing color and nutrients, leave them. This leaves the corals unprotected and vulnerable to other factors like disease or predators. Rising sea levels also pose a serious threat. As polar ice melts and water undergoes thermal expansion, many coastal ecosystems face the risk of inundation. This affects not only local communities dependent on fishing, but the entire ocean ecosystem, as changes in salinity and water temperature can trigger the migration of many marine species to new territories, creating potential conflicts with local ecosystems. It's also worth noting that ocean acidity is significantly increasing due to the absorption of atmospheric carbon dioxide. This phenomenon, known as ocean acidification, threatens numerous marine organisms. Particularly vulnerable are those forming carbonate shells, such as mollusks and some types of plankton. Declining populations of these organisms can trigger a chain reaction, leading to reduced biodiversity and disruption of food chains that have evolved over millions of years in stable ecosystems. New types of marine inhabitants might be able to adapt to the changed conditions. However, this process requires significant timescales, and not all species can evolve quickly enough to survive. Many researchers indicate that if climate change continues at current rates, we could face the extinction of up to a third of all marine species. Those that survive may be entirely different from their ancestors. The formation of marine ecosystems with altered faunal composition could lead to new undesirable phenomena, such as the invasion of invasive species capable of displacing native species and disrupting the established balance. I already see this in some regions. In areas where environmental conditions have become more favorable for certain species, like pufferfish and sea urchins, traditional species are losing ground. In the short term, this could lead to declining fish stocks and worsening food security for millions whose livelihoods depend on fishing. Irreversible changes in ocean ecosystems present a serious challenge to the entire global biosphere. Scientific communities and various organizations are actively working on methods for monitoring marine conditions and developing measures for biodiversity conservation. However, the key remains the need for global action to reduce greenhouse gas emissions, which in my firm belief are the primary cause of climate change and consequently the activation of these processes in the oceans. People must realize that their actions directly impact the health of the planet and all its inhabitants. Throughout its history, humanity has actively interacted with nature, but the pace of this interaction in recent centuries has reached unprecedented levels. Alongside scientific and technological progress, we are beginning to understand that we exert significant influence on the planet's ecosystems and climate, which could have irreversible consequences in the near future. This concerns not only climate change caused by global warming, but also numerous other factors, such as pollution, depletion of natural resources, and destruction of natural habitats. By launching the Industrial Revolution, humanity made a huge leap forward. But in this race, we often forgot the vital necessity of maintaining balance in nature. As a result of the excessive consumption of fossil fuels, coal, oil, and gas, the atmosphere fills with carbon dioxide and other greenhouse gases, leading to rising global temperatures. This in turn threatens rising sea levels and more frequent, intense weather anomalies, hurricanes, floods, droughts. Every year, I watch with anxiety as natural disasters claim lives, destroy cities, and devastate entire ecosystems. Forests are cleared for agricultural land, destroying habitats for countless species. Experts estimate that current species extinction rates are tens of times higher than natural background rates of the past. If decisive steps aren't taken, the consequences could be extremely grim. We might face mass extinctions, including species upon which our own survival depends. Regarding finding ways to preserve our planet, I think it's worth remembering the need to rethink our consumption patterns. Sustainable development, environmentally friendly agriculture, and the use of renewable energy sources are becoming priorities. These aren't just fine words, they represent a complex set of real actions capable of neutralizing the threat looming over humanity. Technological innovations such as solar panels or wind turbines help reduce dependence on fossil fuels and cut carbon dioxide emissions. Every year I see such projects becoming not only more accessible, but also more economically viable. But there are other aspects to this situation that cannot be overlooked. Education plays a key role in fostering environmental responsibility. By teaching the new generation to respect nature and understand their role in its preservation, we lay the foundation for future positive changes. Involving children in conservation projects, participating in tree planting campaigns, and volunteering initiatives shape a new worldview capable of active efforts to protect our planet. The more people are aware of environmental problems, the higher the likelihood they will want to do something significant in this area. In this context, in my conviction, international cooperation is indispensable. Environmental protection issues require a global approach. This approach must be based on common interests and mutual respect between countries. The need to legally anchor environmental protection programs at the international level is becoming increasingly urgent. Only by acting together can we effectively tackle large-scale problems like climate change or biodiversity conservation. Thus, the responsibility for Earth's future lies with each of us. Our planet is a shared home for all living beings, and its well-being depends on our attitude towards it. I strive for our civilization to leave behind not only technological achievements, but also preserve natural resources for future generations. By supporting environmental projects, educating youth, and fostering international cooperation, we can make the world better today, surrounding it with care and respect for all life. Geology, oceanography, and climatology are not just scientific disciplines studying the Earth. They are powerful tools allowing us to peer into our planet's future, to see it in a state of constant transformation. Scientific research in these fields enables us to identify trends that seem hidden from a superficial glance, but play a fundamental role in shaping our environment. Plate tectonics, as I've mentioned, is central to many processes. Each movement of these plates can lead to the emergence of new mountain ranges, or conversely, the erosion of existing ones. For example, subduction zones, where oceanic crust sinks beneath continental crust, can generate volcanic islands that then become important ecosystems for flora and fauna. The process of plate collision not only causes earthquakes, but also fosters the formation of new ecosystems, altering living conditions for countless creatures. Geologists studying these regions can predict when and where such changes might occur, based on data from long-term observations. Furthermore, oceanography allows us to assess crises already unfolding and set to intensify in the future. Monitoring ocean temperature changes, sea levels, and currents not only reveals the current situation, but also provides valuable information about what our marine environment will look like. Diverse marine life is sensitive to changes in sea temperature caused by climate shifts. Cooler, Oxygen-rich waters favor the active reproduction of certain species. Conversely, rising temperatures and changing salinity can lead to the disappearance of others. These dynamic processes allow us to forecast changes in fisheries, marine ecosystems, and even influence the global economy. Climatology, in turn, is inextricably linked to all these processes. By studying past climate fluctuations, we can predict how the coming decades will affect different regions of the Earth. I see that we are facing climate change occurring much faster than ever before in human history. Based on historical data on temperature, carbon dioxide levels, and other climate variables, we can create models that help society adapt to future conditions. For instance, predicting which regions will become drier and which will be prone to flooding. However, effective forecasting requires new methods and technologies. Modern tools such as satellite data and global climate models allow us not only to record the current state, but also to see the long-term picture. This means we can adapt in advance to potential habitat changes, for example, by altering agricultural practices or improving water resource management. The key point, in my view, remains that scientific research should not be isolated. Only an integrated approach, combining geology, oceanography, and climatology, can give us a full understanding of the interconnections between processes occurring on Earth. Understanding these interconnections is vital for our society to develop strategies for survival and sustainable development. Each of these disciplines provides a unique perspective, and their combined application yields the most complete picture. Understanding long-term forecasts becomes not just a fascinating study, but a necessity for all of us who care about the planet and future generations. The future of our planet and humanity presents a unique picture, full of uncertainty and mystery. Throughout history, there have been numerous apocalyptic predictions about Earth's future, based on climate change, natural disasters, and cosmic threats. But at the same time, each such prediction carried not only news of catastrophe, but also the potential for evolution, adaptation, and possible breakthroughs in human development. Modern times are no exception. Humanity faces global challenges. More than ever before, we must take responsibility for our own destiny. The possibility of a new supercontinent forming in the distant future is one characteristic feature of geological activity. However, when it comes to human life and well-being, it's important to remember not only tectonic processes, but also how we ourselves impact our planet. Growing evidence indicates that climate change caused by human activity could create critical conditions for life on Earth. This is linked not only to rising atmospheric carbon dioxide concentrations, but also to resource depletion, water and soil pollution, and ecosystem destruction. The technologies we are actively developing can open new horizons for us, from clean energy sources like solar and wind to scientific advances in ecology and pollution control. Although the trend towards improvement is noticeable, it still requires global attention and conscious decisions from each of us. Mindful consumption, rethinking our approach to resource use, and the principles of sustainable development must become the foundation of our interaction with nature. Can we create conditions for harmonious coexistence with nature and ourselves? The ways humanity adapts to changes depend not only on technology, but also on our ability to act together. We must be prepared for serious catastrophes, from earthquakes and floods to epidemics. But it is often in times of crisis that rapid development of ideas, technologies, and more sustainable approaches occurs. Collective social responsibility, support for scientific research, and environmental initiatives could lead to a single catastrophe changing our mindset, transforming us from conquerors of nature into its guardians. Thus, evolution and adaptation will become not just survival in difficult conditions, but the development of a new philosophy of life based on respect for the Earth, understanding its processes and their complexity. Our planet has repeatedly demonstrated its capacity for self-renewal, but this capacity largely depends on how willing we are to support its existence. We need to learn from the lessons of the past to ensure a bright future. Dear readers, I ask you to reflect on what legacy we will leave for the next generations. What comes after us directly depends on the steps we take today. Perhaps it is in these decisions that our future as a species lies, a species capable not only of surviving but thriving in a constantly changing world. Therefore, let's raise these important questions and engage in dialogue about how we can save our planet and make life on it more favorable for all inhabitants. With each new discovery, people increasingly ponder what lies beyond our planet. Artificial satellites and probes exploring other planets gradually help us build a more complete picture, but we also have a unique opportunity to look at Earth itself as a kind of cosmic microcosm. Within this microcosm lie clues about the possible existence of life in other systems. Every new study of our planet's interior, its atmospheric conditions, and geological processes helps not only to understand the conditions necessary for life, but also to grasp how our own ecosystem might look in the long term. Earth, as we know it, is exceptional in its dynamics and diversity, and it is precisely this diversity that could form the basis for searching for similar civilizations within our solar system and beyond. If we ever encounter life forms on Earth-like planets, what exactly should we look for? What signs might indicate their existence? Stable, slowly changing ecosystems, as well as the ability to adapt rapidly to new conditions, could create prerequisites for highly developed civilizations, potentially leaving traces discernible even after millions of years. We know that climate change can leave its imprints in geological layers and sediments. This makes one wonder if such changes could have been caused by the activity of intelligent beings in the distant past. In this context, exploring planets, especially ones like Mars, we try to find remnants of ancient civilizations, artifacts, traces of structures, or even technologies. Looking at the consequences of human activity on our Earth, I cannot help but ask, how unique is it on the scale of cosmic civilizations? Could other intelligent beings possessing advanced technologies have left their marks on the surfaces of twin planets? The answer to this question might be sought by analyzing the composition of atmospheres and minerals. Therefore, it's important to study potential habitats for life in the solar system, from the moon to the moons of Jupiter and Saturn, where oceans with signs of life might hide beneath the ice. Every finding, every new understanding of an ecosystem can radically change our perception of the possibility of highly developed civilizations that might have once inhabited planets, for instance, ancient Mars. Furthermore, by studying the geological features of other planets, we can find parallels with our own evolution. Possible impact craters, traces of volcanic activity, or even dried-up river systems can tell us about the influence of climate change on planet's habitability. Perhaps each such element is an important step towards understanding how life might have existed or vanished in different ecosystems. Research in geochemistry and mineralogy allows us to gather evidence supporting the existence of past civilizations and their possible technologies. Each discovery can reveal new aspects, helping us understand not only our past, but also predict the climatic future. By conducting these studies, perhaps we instill hope that one day we will find signs of life activity from other beings, who left their traces in rocks similar to those found on Earth. Thus, our research ultimately becomes not only a search for an answer to whether life exists on other planets, but also a study of how we ourselves can adapt and transform the world around us. Even under the pressure of time, in the modern world, we face growing challenges related to the state of our planet and the effective management of its resources. Climate change, biodiversity loss, and environmental pollution are not just abstract problems. They directly affect each of us, every decision we make, and every action we take. We live in a unique historical moment when scientific understanding of Earth's processes has reached a level where we can not only assess the current situation, but also actively influence its development. This responsibility rests on humanity's shoulders and obliges us to consciously use our knowledge and resources for the common good. Each of us, starting small, can contribute to improving the state of the environment. These can be simple actions like sorting waste, reducing plastic consumption, and avoiding single-use items. Even minor changes in our lifestyle can have a significant impact on the scale of the problem. If every person on the planet takes just one step towards more sustainable consumption, the results will exceed the most optimistic expectations. Numerous initiatives aimed at preserving ecosystems and restoring resources need support and participation specifically from society. However, it's important to realize that transformations won't happen overnight. Sustainable development is a long-term goal requiring a comprehensive approach and the participation of all segments of the population. Politicians, business leaders, and ordinary citizens, everyone must work in unison to achieve the set goals. Modern technologies and scientific research can be powerful aids in this endeavor, allowing us to find new methods for environmental protection and rational resource use. For example, advances in renewable energy help reduce dependence on fossil fuels and minimize CO2 emissions. Every year, I see such projects becoming not only more accessible, but also more economically viable. But there are other aspects to this task that cannot be overlooked. Education plays a key role in fostering environmentally responsible consciousness. By raising the new generation with respect for nature and awareness of their role in its preservation, we lay the foundation for future changes. Engaging children in environmental projects, participating in tree planting campaigns, and volunteer initiatives shape a new worldview capable of active efforts to protect our planet. The more people are informed about environmental issues, the higher the likelihood they will want to do something important and meaningful in this area. In this context, in my opinion, international cooperation is unavoidable. Environmental protection issues demand a global approach based on common interests and mutual respect among nations. The need to legislate environmental protection programs internationally is becoming increasingly relevant. Only through joint efforts can problems like climate change or biodiversity conservation be effectively addressed. Thus, the responsibility for the future of Earth lies with each of us. Our planet is home to all living beings, and its health depends on our relationship with it. We must strive for our civilization to leave behind not only technological advancements, but also preserved resources for future generations. By supporting environmental initiatives, educating the new generation, and collaborating on the international stage, we can make the world better today, showing care and respect for all living things.